All right, so I'm going to go over all the questions from the non-calculator practice quiz. Again, you can jump around and just kind of go over the ones that you either didn't get right or that you know you guessed on, just kind of figure out how to do these problems the way you're kind of expected to. All right, so question 1, we're asked to find the integral of x squared over 4 dx. Remember, this symbol here is just a shorthand for the antiderivative. All right, so if we know our reverse power rule, we add 1 to the power and divide by this new power. It's going to be x cubed over 4 divided by that new power 3. And when you divide by two numbers like this, they actually combine. I'm going to get x cubed over 12. And luckily, it doesn't matter if we remember the plus c because all of them have plus c. The x cubed over 12 is b. All right, which of the following is an equation of the line tangent to the graph y equals cosine x at x equals pi over 2? So if we want to find a tangent line, the thing that gives us the tangent lines are our derivative. So if our function is y equals cosine of x, the derivative is going to be negative sine of x. And then if I want to make a line, the formula we use for the most for the lines is point slope form, y minus y1 equals m times x minus x1. So we need to figure out three things. We need to figure out the original x and y value. Those are going to come from our original function y. And then our slope, that's going to come from our derivative. So if I plug in pi over 2 into cosine of pi over 2 is 0. So my x value is pi over 2, the y value is 0. And the slope of my tangent line is when I plug that same x value, pi over 2, into negative sine of pi over 2, you're going straight up to that point 0, 1. That's going to give you 1 with the negative sign in front of it. As now I put that all in, y minus 0, negative 1, x minus pi over 2. The left-hand side simplifies to y. The right-hand side, that negative distributes, negative x plus pi over 2, which is going to be c. All right, so c is the tangent line at that value. All right, 3, d dx. All right, this is the shorthand notation for derivative. Right. So we're going to find the derivative of this. All right, this is a chain rule problem. The first thing, we have this kind of 2, which is just a constant that's sitting out in front. So we can just leave the 2 in the front of everything. And then the real thing we have to take the derivative is all of this. And they do this a lot. They don't put these kind of extra parentheses after the sign. So I like to put that extra parentheses there to remember that the square root of x is inside of the sine function. Right. But when we do the chain rule, we start from the outside in. So the first thing on the farthest outside in this green box is that exponent 2. So that's the first thing I'm going to take care of. When I do an exponent, I bring the exponent out in front. I'm going to leave everything else on the inside the same. And I subtract 1 from the exponent, so that's to the first. And then I multiply, I move, now I've kind of gotten rid of that, I move into the next thing on the outside, which is going to be the sine. And we know the derivative of sine is cosine. And we're going to keep the thing on the inside the same. And the last thing, what color have I not used yet? Green. The last thing inside of that was the square root of x. So we had to multiply by the derivative of the square root of x. X to the 1/2. Its square root becomes 1/2 x to the negative 1/2. All right, now we just need to simplify everything. We have a 2, a 2, and a 1/2, so these are going to cancel. And we're going to have a 2 at the front, so chances are those ones are gone. And then the only one that has a cosine that's left is d. Okay? And that d is the answer because this negative 1/2 power here turns into that square root on the bottom there. All right, so for this one, we want to find the integral, which again just means antiderivative of this function. All right, and this one looks fairly complicated. All right, we have this kind of quotient, we have an exponent. But whenever you see something complicated inside of something else, this is where you think about our substitution. And the way we did that is we're going to make u equal to the thing that's inside that parentheses. All right, so not the whole bottom, but just the thing in the parentheses. Then we take the derivative, so the derivative of u is du. On the right, we're going to get 3x squared plus 3 all times dx. And I like to solve for dx, so du over 3x squared plus 3 equals dx. All right, so now I can rewrite this integral. It's going to be the integral of x squared plus 1 over u cubed times, and we replace dx with du over 3x squared plus 3. And do some simplifying, but on this right hand, or this denominator here, I can factor out the 3, and it's going to become 3 times x squared plus 1. So you can see these x squared plus 1s are going to cancel, and I'm going to get the integral of 1 over u cubed times du over 3. All right, this 3 here I can kind of pull out at the front, so I can just do 1/3. And then how do we take the integral of something like this? So I get the 1/3 is going to hang out. We rewrite it with a negative exponent. And then we remember our reverse power rule. We add 1 to this exponent, divide by the new exponent. That's just going to be, sorry, I'm kind of running out of room. Negative 1 over 6, u to the negative 2. And if we have a negative 1 over 6, which one is it going to be? Well, it's not going to be C or A. And this one doesn't have the entire u thing on the bottom, right, versus this one does. All right, so this is our u going on the bottom because of the negative 2 exponent. This is our negative 1/6, and then plus C. So the answer is D. And so this one is using our substitution to take the integral, the antiderivative of some function. So for this question, they give us the function f, and we know when is it concave up. So if you're figuring out when something's concave up, you have to know when the second derivative is positive. So this whole question is really saying, when is the second derivative of this function positive? All right, so we have to find the second derivative first. To do that, we find the first derivative. All right, power rule, 12x squared minus 3x, oops, sorry, I messed that up, 4x cubed. All right, just bringing down the exponents and subtracting, and the second derivative would be 24x minus 12x squared. And so now, if we want to figure out when it's positive, we kind of have seen this before. What we're going to do is first figure out when it's 0, because 0 is kind of the differentiating point between positive and negative. So I'm going to take this equation and set it equal to 0. I'm going to factor a bit, so I can say factor out of 12x. It's going to be a 2 minus x. This factor tells me x equals 0. This factor tells me x equals 2. So 0 and 2 are kind of the possible cutoff points, but we don't know what happens in the between those areas. So we can do some test points. To the left of 0, let's just say we choose -1. Between 0 and 2, we'll choose 1. After 2, we'll choose 3. And you don't have to use those specific test points, but those are like the smallest numbers are going to be easiest to try. And we're trying to figure out when the second derivative is positive or negative. So I'm going to take these test values and plug them in to the second derivative. If I plug in -1, this would be negative. This would be negative. That's going to be positive. If I plug in 1, this would be positive. This would be 2 minus 1 is also positive. I thought it would be positive. That doesn't seem right. What did I do wrong? Oh, 2 minus -1 is positive. So positive and negative. This first part should have been negative. And I plug in 3. 12 times 3 is positive. 2 minus 3 is negative, so that's negative. So the only place it looks like that the second derivative is positive is between 0 and 2. So C is the right answer. And again, I made a mistake plugging in -1, but if you're a little bit more careful on the actual exam, hopefully you see that when you plug in -1, you actually get a negative answer out. All right, but kind of figure out when the second derivative is 0. They kind of give you the break points. All right, so 0 and 2 are the possible places you can change. And then you just do a test point in each of those regions to figure out when it's actually positive. All right, for this problem, they're asking us to find dy dx at this point. And you may notice that we have this equation here where kind of y's and x's are mixed up. So whenever you see an equation like this means we have to do implicit differentiation. All right, so what does implicit differentiation mean? It means when I take the derivative of something, I have to add on that dx or dy parts. The derivative of x is just 1. But because I took the derivative of x, I'm going to put a dx after it. Okay. The derivative of 3y to the 1/3. All right, when I take the derivative of a power, I bring it down, so I'm going to get 3 times 1/3 y, and I subtract 1 from 1/3, get negative 2/3. But because I took the derivative of something with a y, I multiply by dy. On the right-hand side, the derivative of y is just 1. But again, I took the derivative of something with a y, so I put a dy. And now to get dy over dx, I'm going to group up the dy's on one side and group up the dx's on one side. So on the left, I'm just going to keep this dx. On the right, I'm going to get 1 dy minus the 3 and that 1/3 cancel out. Minus y to the negative 2/3 dy. I can factor this dy out and then divide. I'm going to get dy. Oh no, I can't do that because I want to get dy dx. So I'm going to do it the other way. I want to divide both sides by dx and divide both sides by, this is going to turn into dy. Negative 2/3. So I'm going to move this over here and this over here. I'm going to end up getting 1 over that right-hand side equals dy dx. All right, so that's an implicit differentiation. Pretty much whenever you take the derivative of an x, you get a dx. Derivative of y, you get a dy. And just move things around so you can get dy dx. Right. And now we want to do it at the point 2, 8. So I'm going to plug in 2 for x, where there's actually no x's in the equation, and 8 for y. So I'm just going to plug in an 8 for y. And really now this whole problem is going to come down to what is 8 to the negative 2/3. Right, well, 8 to the, let's just do to the 2/3. We'll worry about the negative in a second. Is 8 to the 1/3 squared. And just like we know the square root is the 1/2 power, the 1/3 power is the cube root, so that's 2. And that's 4. And because it is to the negative instead of 4, if I put a negative on all this stuff, I'm going to get a 1/4. And 1 over 1 minus 1/4 is 3/4. And whenever I take 1 divided by a fraction, that's going to flip the fraction to 4/3. So this is an implicit differentiation problem. Take the implicit derivative and then plug in 2 and 8. In this case, there was no x's left, so we're just really plugging in that 8 for the y value.